Hi there. In this video, we will learn about the mutually exclusive projects and how we can choose among or between such projects. Primarily, we need to understand that what is a mutually exclusive set of alternatives. Basically, it's a situation in which we can achieve the same objective by undertaking either of multiple options or alternatives. So they are known as MEPs, or mutually exclusive projects, or mutually exclusive alternatives. They are mutually exclusive because if we undertake one, we should not undertake the other, because that will be wasteful expenditure, something which is against the very definition of public sector economics. So now we can consider that mutually exclusive alternatives or projects, they are either alternatives in the form of complete projects, or they are alternatives in the form of different designs of the projects. So the same project can be undertaken with different designs. For example, a project can be undertaken in a capital intensive technique of production or labor intensive technique of production, or we can undertake different projects and they are all aimed at the same objective. So they will be completely different projects, not just change in the technique of production, for example. So we already know that if we undertake one of them, the others will be discarded. And we can remember that COVID-19 vaccination is there, and its alternatives are also being worked upon, that is the drops instead of injections. So these are two mutually exclusive alternatives, and if we go for injection method, we should not go for drops method, and vice versa, because if we go for both of them, that will be wastage of the resources. Definitely drops will be preferred because they require less of the technical inputs, where the injection gadgets will be used, and here in the drops there will be only droppers, and they are easy to conduct as well. So different possibilities can be there. For example, we can delay the benefits, or we can analyze the delay in the benefits. So the same project is being undertaken, but with different timings of the benefits, with a little delay or more delay or no delay. So it will give rise to some MEPs. Then we can change the scale of alternatives, larger scale, smaller scale. This can be another study that we can do. Different timings of a project, different timings, that is if the project starts later or sooner. Here it is not just a matter of benefits, it is the matter of costs as well. So both costs and benefits will be shifted to some other point in time. Choice of technologies, we talked about a similar thing, that we can go for capital intensive and labor intensive alternatives. Then we can choose the more suitable or most suitable if there are more than two alternatives. Finally, there is another possibility of MEPs, that is, we have additional purposes, and it is a multi-purpose project. One project can aim at more than one objectives or purposes, so then we can choose that which one of the options is good for us. Now, NPV Criterion, as we have already experienced, has been the most reliable among the other discounted measures of project worth. So we will consider NPV here instead of using IRR, BCR or NKR, because they can lead to incorrect decisions. Now let's start with the first one, that is the assuming the benefits delay. In this video we will focus on this possibility only, and the remaining will be explained in the other videos. Now this is the focus of this lecture, that we will focus on the benefits delay. It can be delayed, that is the benefits, and there can be different situations, and we will consider these situations in this table. And what we can do is we can undertake the option in which the NPV is maximized or is at the highest level. Now this is a table in which we have years. In the first column, it is starting from 2022 and going to 2041. And we can make serial number for the time periods. It starts from 1 and it goes to 20. So it means that it is a project of 20 years. Then we have calculated the discounting factors, and these are calculated at 12% discount rate. So you can see this series of discounting factors calculated at 12% discount rate. Now we have costs, and they start from the first year, and we can see that these values are going into the future, that is up to 2041. Let us see that if it is continuing for a longer period of time. No, this is the final year, that is 20 years. And then we have the benefits, and they are starting from the first year. So this D basically shows delay, and this value in the parentheses is showing that how much of the delay has happened. So you can see that the delay is not there. Zero delay is there in terms of years, and you can see from the very first year, from when the costs they started to occur, the benefits have also started to occur. So this is one possibility, and you can see another feature of this stream is that from the ninth year, the benefits they have become constant, and they are remaining constant till the end. Then we have the benefits delay 1 years. Now definitely 1 year delay will happen, and we can see that same values are being shifted one step downwards. And here we are, the values they are shifting one step downwards, and that's where the constant value starts. It was starting at 9th year, but now it is starting from the 10th year, and it remains the same. So the final value, this value, gets truncated, and it's not to be seen in here. Then we have other possibility. We are assuming that there are 2 years, there is a delay of 2 years, and the first 2 years are not giving any benefits. Then the same set of values are being shifted one step downwards, as you can see again, one step downwards, and this will be the end. Then we have a benefit delay of 3 years. So the first 3 years are having no benefits, and then the same column has been shifted one step downward. Here we are, those values. Now we have constructed the table, and we can experiment with these 4 possibilities, that is no delay, delay of 1 year, delay of 2 years, and delay of 3 years. Now we will solve these to find out the NPVs, so that we become able to take a decision. So here we are in this new table. We have brought these columns that were there before. Discounting factor is now highlighted in a certain color, and the purpose is that we are going to use this set of values for all the possible cases. This is the cost column, this is the benefit column. Now these 3 columns are belonging to this outcome, and the benefits, they are starting from the very first year. The net benefits have been calculated by the difference of these 2 variables, benefits minus costs, and then we have calculated all these values. So these net benefits can be discounted in the next step, and here you can see they have been discounted using this discounting factor, and here we are, these are the discounted net benefits, and then we sum these vertically, because this should give us the NPV at 0 years delay. Then we have the other possibility. We must know these values, and the other possibility is that there is delay of 1 year, and here the benefits are not there for the first year, and the remaining values are already there. We have seen them in the previous table. Same process will be repeated. Net benefits will be calculated by the difference of this column and this column. Cost will remain the same, because only the benefits have been experimented. So again, the same process of finding the discounting net benefits. Here we are, these values, and then we have a sum of these. Then we have benefits delay of 2 years. Again, first 2 years of the benefits, they are blank, and then there are values. Then we have definitely the next thing, which is the net benefits, the difference of the benefits, these benefits with the same cost. Now these are the values after subtraction, and then we have also discounted them by using the discounting factor, which is mentioned here. So we note the NPV, which is actually the sum of all these values, just like this was the sum of all these values, and again this was the sum of all these values. Then we have benefits delayed for 3 years. Here we are, the first 3 years are having no benefits, and then the benefits start, and then the net benefits calculated on the basis of this column. Then we have the discounted net benefits. Finally, we have the NPV, which is equal to this. So this is the way of finding the NPVs, NPV with 3 years of delay in the benefits. Now I can compare these values, all these NPVs. I have placed them in a table, and here is the table. So in the first column we have delay, no delay, 1 year delay, 2 year delay, and 3 year delay. And these are the NPVs. The NPV when the benefits start occurring from 2022, from 2023, from 2024, and from 2023. That is 3 years of delay after 2022. So this is the NPV for no delay, 1 year delay, 2 year delay, 3 year delay. Clearly we can see the delay is not there in this case, and the NPV is the greatest in this case. And here the NPV is negative, so further delay is now actually making the project infeasible, because there is a gradual decrease from this point to that point, and then further decline, and then it enters into the negative range. So delay is in this case playing a negative role for the viability of the intervention. Graphically speaking, here you can see it's very much clear that starting the project in 2022 for its benefits, it is the most desirable situation. A delay is causing decline in the NPV, and finally the NPV becomes negative as we delay it by 3 years. That is the benefits. So this is the conclusion, that we should start the project without any delay. Otherwise, if the delays happen in the benefits, then the outcome will not be desirable. In real life, definitely there are situations when the project is established, but it is not started because of some sort of political vested interest, some intervention, some lack of consent or willingness of the state to begin it due to certain reasons, or any natural calamity, etc. So these factors can lead to delay in the benefits, and hence the outcome can change. So we should do this analysis before every project. Otherwise we will not be aware of the effect of the unexpected delays or intentional delays that we might do just to maximize the NPV. So this is how we do this. This was the calculation table, and this was the table in which we developed the delayed benefits columns. Here we are. And finally, this was the first case out of the 5 cases that we have, where we will study the selection between the mutually exclusive projects. Thank you.